Girls, Lewis structures can sometimes be complicated, but you need to understand that it is how electrons are arranged around an element that determines what happens and how they will form bonds. If you look, for example, at SO2, one sulfur and two oxygens. Now, if we look at sulfur, we see that sulfur has two available spaces. So if I arrange the 6 electrons, remember sulfur is in group 6 and so is oxygen. So the 6 electrons, if I arrange it in the same way that I arrange electrons into electron structure, in other words, the s orbital immediately gets 2, 3, 4, 5, and I come back and I put the 6th one in here. Sorry, I'll go back into view now. Go put the 6th one in there. I clearly see that I have 2 available spaces for sulfur to form bonds. Oxygen will look exactly the same. Why? Because it's also in group 6 and it also has 6 valence electrons around it. Now, what the sulfur will do is sulfur is going to form a bond, 2 bonds with 1 oxygen. So the 1 oxygen is going to form a bond with sulfur, and so is the other oxygen. So remember, we want to follow the octet rule. So that means if I have 4 shared bonds around carbon, I will have 8, right? So if I have a double bond here and a double bond there, 2, 4, 6, 8, that gives me the octet. I'm now obeying the octet rule. So that means sulfur is going to deviate from this pattern. It's not going to have just 2 half-filled orbitals where it's going to share. It's going to share more than once. It's going to take these electrons that they have here and it's going to start sharing it with those oxygens. So sulfur has the 4 bonds around it. Oxygen, 2 oxygens, because I have 2 oxygens, will each combine onto it. Once I've done that, I need to make sure that my oxygens also have 8 electrons around them, because they will also obey the octet rule. So this is 2, 4. That means this oxygen will have 6, 8. It would have 2 lone pairs of electrons that is going to be on that molecule. So 2, 4, 6, 8. So now that oxygen is also happy. My sulfur is happy. Why? Because 2, 4, 6, 8, there is its 8 electrons. So now I need to make this oxygen happy as well, because it's 2, 4, 6, and 8. So the SO2 molecule the SO2 molecule will look like this. Now when I get to SO3, it's going to be a little bit different, because also bear in mind this is an ion and it carries an ionic charge. But again, my sulfur will obey the octet rule. I have a sulfur and I have 3 oxygens. Now, one thing that I can already tell you is whenever you have 3, you will always end up with a triangle. Whenever there's 3 involved, you're always going to end up with a triangle. So in this case, sulfur must have 4 bonds. It can form a single and a single, but then it means that one has to be a double. So that 2, 4, 6, 8, I have obeyed the octet rule. So for SO3, I will have a single bond, and then a double bond. But then I also need to make sure that my oxygens have 8. So this one's got 2, 4, 6, 8. Now it's happy. Sulfur is already happy. 2, 4, 6, 8. This one's happy. 2, 4, 6, 8. So this one won't have 3 lone pairs of electrons. It will only have 2. So that will be my SO3. And because it is 2 negative, I will have to put it into a bracket and put the 2 minus onto it to show that it's SO3 2 minus. When I get to SO4, well, again, just like there, with 3 I have a triangle, but when I have 4, believe me, you are going to end up with a square. There will be an oxygen on each corner. Okay, so what do I do next? Well, sulfur can only form single bonds. So sulfur is happy, 2, 4, 6, 8. And then it's just left for me to make all the oxygens happy, 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Right, so my Lewis structure is for SO4 2 minus. I will go and put it in a bracket, 2 minus. Now, something that you need to know about this molecule 2 is that if you want to find out which one of them would have the strongest bonds between them, clearly it would be this one, because there are 2 double bonds. So they're going to be pulled close together. The strength of double bonds are much stronger than that of single bonds. So the strongest force of attraction is going to be between these two, because there's 2 double bonds. In this one, the forces will also be stronger because there's a double bond here and 2 single bonds. Remember, single bonds are weaker than double bonds. And then SO4 2 minus, if you look at SO4 2 minus, these are going to be the weakest bonds because these are only single bonds. If I want to see which one of them are going to be the shortest out of all of these, which bonds are going to be the shortest, which is going to be the closest, it will definitely be this one. If I want to know which ones are going to be the furthest, it's going to be this one. So remember, single bonds, elements are far apart, double bonds, they're closer, and if there's 2 double bonds, they will be even closer. The strength of the bonds are going to be even greater.